Then let's get started. We're going to be talking today about C#8. Now, if you read the description for today's talk, you might have seen a little bit of not quite a truth. C#8 has shipped with Visual Studio 2019, but it was as a preview. So we have to write these abstracts a couple months in advance, and I try to take my best guess. My best guess was quite a bit wrong. There's still a lot available in Visual Studio 2019 for you to go home and play with. That's what I'm going to show you today through demos. But the full C# 8.0, the full final list of features, the full language experience out of beta is not going to be until later this year when .NET Core 3.0 ships as well. And look for that announcement as to a particular date at the upcoming Build conference. So with that, I unfortunately have to give you this warning that the features we're going to be talking about today are in alpha and beta stages. They may change, and some of them very likely will change between what you see now and what's finally released. If you've been following along C#8 development, it's been going on for about 2 years or so. A lot of these features have been in early alpha and experimental phase for quite a while. And along the way, quite a bit has changed. So it is an agile development. Stuff is constantly being realigned based on everyone's feedback. So I'm Scott. I'm a lead engineer at Grubhub. I work on the core backend systems. I don't do C# during the day anymore, but I still have a lot of fun with my side projects, and I still love the language. So I'm very happy to keep following it and seeing all the progress they're making over the years. So today we're going to first briefly look at some of the recent history of C#. There's been a lot of releases over the past 2 years. I just want to review some of them so everyone knows where we are today. Start talking about an overview of what to expect in C#8. We'll talk about compatibility and kind of where you can run your C#8 code. We're going to look at all the features that are released in the, I'm calling it Preview 1. That's everything that's out now with the final version of Visual Studio 2019. The internal version number is 16.0. And then the next minor release, the next point release for for Visual Studio 2019, looks like it already has a few extra features that are going to be shipped with it. I've compiled that code locally so we can play around with some of that today. All right, so let's take a look at some of the recent history of C#. We'll start in 2015 with the release of C# 6.0. And this is particularly noteworthy because we got a brand new compiler from Project Roslyn. The C# compiler up until this point in time was written in C++ and in such a way that it was difficult to maintain. So adding new features to the language were very expensive. So you got major new things like async and before that dynamic. But smaller features that the community was asking for, really didn't make it through because the amount of work necessary just didn't justify the expense. Not to mention Visual Studio, the part of Visual Studio that gives you all those squigglies and warnings and errors and guidance was written with an entirely separate code base, so you at least had to do everything twice. With the new Roslyn compiler, Visual Studio itself is using Roslyn. Roslyn exposes all of its internal state, everything it knows about your code, all the flow, all the analysis. It exposes that through APIs. That's what Visual Studio has been using now directly in order to show you these features, show you the IntelliSense and all the squigglies and warnings you get. So that's the same code base now, and it's a more modern code base. It's actually written in C#, and it's enabled them to write things a little bit quicker. Roslyn also is a fully open source project. So not only does Microsoft create new features, but the community does as well. And there's vibrant discussion. Even if you don't want to write a new language feature for the compiler, there's still plenty of opportunity for you to inject your opinion. And it's not too much traffic yet on those sites, from the GitHub sites. I'll show you that a little later. That if you do post a comment, chances are someone from the language design team will actually read it and take it into consideration. Of course, don't be disappointed if your particular suggestion doesn't make it through, but they do care about the community's opinion as a whole. So there was a lot of features introduced in C# 6 with Roslyn. A lot of them were what the community was asking for a very, very long time. Back when I think user voice was a very popular thing, this is basically the top list of what people wanted on user voice from C# as a language. Roslyn is also part of the .NET Foundation, which is the official open source community, or I guess they manage all the patents and all the legal stuff, and make working with .NET in the open source world a possibility. And Roslyn is part of that. They were both announced around the same time at a build conference. In C# 7, released 2 years later, we got tuples and pattern matching, and a wide array of other smaller features that people were asking for. Then we got into point releases. So you don't have to do major releases every single time. There doesn't have to be 7, 8, 9. If there's things that don't necessarily constitute an entire major release, a major number version revision, you can still put them in minor releases. Now, up until this time, there was only one previous minor release to C#, and it was super minor. It was like 1.2 that most people forget about. It wasn't very significant, but these are significant. So 7.1 was honestly just a spillover from 7.0, things that didn't quite make the cut in terms of QA. So they were filled in 7.1. Later that year, same year still, in 7.2, there was a lot of performance improvements. So if you're writing high performance C# code, there's a lot more stuff you can do with structures, a lot more stuff you can do with controlling how your memory is allocated and managed. So that was introduced. A lot of these performance features were used in Crystal for the great speed improvements you saw on that web server. Performance continued. In earlier 2018, we got C# 7.3. Where there are still other features being introduced here, the major focus was on still allowing you to write more performance C# code. Not just for web servers, but Unity has become very popular, and C# is one of the major components of Unity. So game developers now are looking to get a little more performance out of C#. So there's ways to skirt around the GC, the garbage collecting, and there's ways to better control what's happening underneath the covers so that you don't get accidental performance loss. And now today we're going to be talking about C# 8.0, where there's a great mix. There are still some performance features, but there's a lot of major new concepts being introduced in the language. First thing you have to be aware, not all of these features are compatible with .NET Framework. So some of these features will rely on types that .NET Framework will not get, and some of these will rely on runtime features, which .NET Framework will not get. We'll talk about that right now. So this is a bit of a shock, right? It's depending on if you're still on .NET Core or we're able to move, if you're still on .NET Framework or we're able to move on to .NET Core. So first, this is really nothing horribly new. The only new thing is that .NET Framework won't be updated. But in the past, there's always been changes required to both the libraries, the types, and also to the runtime itself in order for C# to continue to evolve. So starting with C# 1, for each depends upon the enumerable type in order for that to work. And to be clear, C# and .NET are separate entities. C# is a language that compiles to .NET. .NET is the technology that runs the compiled code. They've always had a close relationship, and .NET in the past has always just been .NET Framework. But that's starting to divert to be a little different right now, and that's where some of this is coming from. In C# 2, there's a great use of generics, but that required you to use .NET Framework 2.0+. So similarly, back in the day, most code was written for either 1.0 or 1.1. Mono did exist in a primitive form at that point, but .NET Framework was still kind of popular. And in order to move to using C# 2.0, you had to move frameworks to 2.0, and that installed side by side was a massive upgrade at the time, similar to what situation we're in today. Even as recently as C# 7, the language depends on other types to exist in the runtime. System.value tuple, right? There's a lot of new features introduced in C# 7 which have special support for value tuple, lets you create them, compare them, special naming conventions. So C# 7.0 will not compile unless it has a reference to system.value tuple. The difference there was that system.value tuple was shipped out of band. So there was a NuGet package released by Microsoft that allows you to get system.value tuple if your runtime didn't support it. .NET Framework eventually added it, .NET Core eventually added it as well. But that actually introduced a few problems. So there was a lot of version conflicts and type conflicts between a mix of using the system.value tuple NuGet package and actually the types built into the runtime. And that caused a lot of headaches for a lot of people. That combined with, there's already lots of really small NuGet packages for .NET features like memory and some vectors and some other things. So they really don't want to continue adding a whole lot more to them. So they are not going to do that. There's currently no plans to do that for the C# 8 types, at least not for Microsoft. In C# 8.0, we're going to go through all the new features. But there's a feature called index and ranges, and that's going to depend on, unsurprisingly, two new types called system.index and system.range. Async Streams has 3 or 4. There's a couple more that are subsequent that aren't on this slide. But there's a bunch of new types required for that feature to be supported. And then we're going to talk about default interface methods, and that requires just features in the CLR, features in the core runtime that you can't patch in with a NuGet package. So that is going to remain, default interface methods, a .NET Core specific feature for the moment. So if you're doing C# 8 and you're not targeting .NET Core for at least a while, you're not going to be able to use that feature. But there are ways still of using index and ranges and async streams in .NET Framework applications, which I'll show you some ways to go about it. But there is risk that you're taking on by doing so. All of the new types are included in .NET Standard 2.1. Now, if you're not familiar, .NET Standard is not a separate runtime, but it's a collection of APIs which are supported as a common denominator across several runtimes. The current version is 2.0. 2.1 is coming up pretty soon. .NET Framework will not support .NET Standard 2.1, which is why it's not going to support all these new features from C# 8 directly. That second new feature, the default interface methods, is actually not officially a part, at least not yet, of .NET Standard 2.1. So specifically, .NET Core 3.0 is supporting all of the .NET Standard 2.1 APIs. But that new CLR feature specifically is only available on .NET Core 3.0, and that's currently in beta stages. So we'll kind of see what happens with that. I do kind of expect this to carry over to other major platforms, just not .NET Framework. Now, Microsoft has said for a while that .NET Framework will continue to be maintained, but will not get new features down the road. They said that a while back. It didn't really matter too much, but now you're starting to see it actually come into play. So the reason why this is a thing is because .NET Framework is a very large, has a very large code base and is a very large application. So making changes to a very large application and not breaking anyone accidentally is very difficult. There have been breaking changes released throughout, even 4.7.1, 4.7.2. It did introduce breaking changes that were completely accidental, but prevented people from using that particular version for their software. So because the risk is very high of breaking someone, it's not going to happen. The other thing you have to keep in mind is how .NET Core and .NET Framework are distributed. There's only 4 possible versions of .NET Core Framework that you can have side by side on your machine: 1, 1.1, 2, and 4. So every update to 4.0 overwrites the existing 4.0 framework you have on your machine. So there's no way to distinguish between feature updates and security updates and patches. So if you want to continue with stability and security on .NET Framework, mixing in feature updates which are potentially breaking is not a very good idea, which is why .NET Framework is going to focus still on stability. It'll still get some new features over time, but nothing substantial, at least not compared to .NET Core. But it will still be maintained and supported. So if you're developing for .NET Framework, don't worry. Microsoft is not pulling that away from you. But if you want to use some of the new features coming to the language, they're not going to be available to you. The good news is .NET Core 3.0 also adds, and .NET Standard as well, adds a lot of new legacy-ish APIs. So if you want to migrate over and you haven't been able to before, there's a lot better chance that you can now. So I mentioned C# is completely open source. The compiler called Roslyn, which is actually also the Visual Basic compiler, is online at github.com/.net/Roslyn. And then there's a separate repository, github.com.net/C#lang. And that's like a meta repository. There's no actual code in there, it doesn't compile, but it's a whole bunch of documentation, and all the issues there are describing and talking about upcoming or potential language features. So let me just show you that real quick. Some interesting places to go. On the Roslyn repo, if you're tuning into this online or if you're here in person, you're probably interested in what features are coming next to C#. So to look at that information at any time in the Roslyn repository, if you go to the docs folder, there's a document here called language feature status. And this will give you a rough idea about what features are currently being implemented in C#8. So these are not proposals. These are proposals that were accepted by the language design team and are currently being implemented at some level. There's prototypes. It kind of tells you what the state there is, what it's been merged into, if it's a prototype, if it's waiting to be merged. You can see this at any time. It's kept fairly updated. But it gives you your best indication of what's currently in development. But there might be a few things here that are slightly off. It's community-driven, manually updated, so things can fall through the cracks. But for the most part, this is your best view into what's currently being implemented in C#. And the current version is C#8. As well for Visual Basic, if you like to keep track, although there are less Visual Basic features in development nowadays. On the C# Lang side, some interesting places to go here. I'm going to start off actually under issues. If you go to issues, there's a lot of discussions about the language, about bugs. Well, not really bugs. Those should go in Roslyn, but sometimes they do creep in here. But if you go to milestones, this is where basically the list of features slated for every version of C#, past, present, and future, is going to be listed. Pay no attention to the due-by dates. They're complete nonsense. Also, pay no attention to the % completed. So this might give you an indication that C#8 is 6% completed. That's not accurate. If you actually scroll down, you'll see versions that have been released, which are also not really marked as completed. So don't look at those as indicators of any sort. Instead, if you click in, like here into the 8.0 candidate, it'll give you a list of features and issues in this consideration for that particular version. Not everything is going to make it in. Right now, there's 44 issues. Now, not all of these are actual feature requests. Some of them are discussions. But there are about 45 or so brand new features under consideration for C#8. About half of those are likely to get in or less. So it gives you an idea about where they're thinking the language can go. But please don't read this as a promise for what's coming. And even the stuff that does make it in, the shape could change before it actually reaches the implementation stage. Now, because it's so agile in development, if you want to see the latest status, hop onto these sites, browse around, and if you don't like what you see, or if you see conversations going in a path you don't agree with, or if you do agree with them, give a thumbs up. But you can participate. It's nothing to be afraid about. So there's not going to be anyone ridiculing you or really trying to diminish you. It's a pretty nice open community. So if you have a new idea or just have a question, just feel free to post it. It doesn't matter who you are, and they just want to hear from the community. And you will typically get your question answered as well. This does not replace Stack Overflow, but if there's some answer you can't find by looking online already, this is a great place to go next. Also, this is not really related to C#8 specifically, but I just want to call out that the language documentation for C# is currently undergoing an upgrade. If you go to the Microsoft's docs, they're actually adding in a new feature in the documentation. Sorry, this is very simple. This is one of the first pages they announced that were converted. So if you see, it gives you some sample code here for very basic mathematical operations. You can copy this code and paste it in Visual Studio, or you can actually run this code. So clicking Run will launch an actual instance of Roslyn, the compiler, and allow you to interact with it right in your browser. This is not just static. I can hear it change the number completely. Run it again, and the output's gonna get reflected. So if you're new to C#, if you go to, there's a little link here that says powered by try.net. If you go here, there's actually tutorials you can take. So if people here are probably familiar with the language, people listening in, but if you're not familiar with C# or want to get a friend interested in C#, send this over to them. There's a very basic introduction tutorial they can take in their browser immediately with an actual C# compiler and get them hooked on the language. So very exciting stuff happening there. Now I mentioned that there's some C#8 features that only work with .NET Core 3.0, and that's currently in beta and does not ship with Visual Studio. So if you would like to try out these features on your own machine, you're going to have to go and download .NET Core. The only thing to be aware of, and .NET Core does install side by side, but some of the .NET Core 3.0 preview installers will automatically remove any other .NET Core 3.0 previews you have on your machine as a convenience feature. You can always go back. It doesn't take long to install. It doesn't take long to uninstall. So they're really easy to play around with. One thing I'll note, if you want to try this locally, I have seen some issues where Visual Studio will be fixed on using the x86 version instead of the x64 version, depending on what other .NET SDKs you have installed in your machine. So if you install the 64-bit version and it's not working, the next thing you should do is try the 32, the x86 version, and give that a try next. I've seen that resolve a lot of people's issues. All right, so what we're going to talk about today, we're going to show you index and ranges. We're going to show async streams, improvements to nulls. So there's null coalescing operator, which is brand new, and there's changes to how null works in generic contexts where there's no constraint. A feature, which is very longly worded, and it's one character, I'll show you what that is later, is the alternative interpolated verbatim strings. We're going to look at static local functions, improvements to patterns, implicitly scope using statements, and also a new change to how using can be extended to reference structures. And we'll talk about nullable reference types. So we'll go through demos for all of these, as well as features that are in some other form of development. So all those features in the last slide are released in Visual Studio 2019 for you to play around with. There's a few things you have to do, including downloading .NET Core 3.0, and I'll show you how to still enable a few things in Visual Studio to play with these features. In C# 2.0, this is the next branch for Visual Studio, so it's probably going to be released with the next point release, that's 16.1. We're going to look at read-only members on structures. An obsolete attribute, there's some improvements you can make there. Those are both smaller features. And then we're going to take a look at default interface methods, which is a pretty cool new feature. And I'll explain kind of why that's been considered for the framework and what that can do for you. So for the remainder of the session, and so far, right? So there could be other things that get in there. This is not the definitive list, and of course, things can be removed from the list. Everything here looks pretty solid so far, and when I've been playing with it at home, so that's a pretty good shot of staying in. So let's move on to demos. All right, so first I'm going to start a brand new project using Visual Studio 2019. This is just a regular released version. Doesn't matter what edition you use for any of this stuff. So I'm using Community. You can use Professional Enterprise as well. I'm just going to create a new project. And here I'm going to search for console. And I'm going to create, for now, a console app for .NET Framework and C#, of course. That's what we're talking about today. So I will keep the default name because I am not creative with naming. And we'll just let this get created. Now, a lot of the features in C#8 do not require any new types to exist in the framework, and they do not require any new framework features. So a lot of what we talk about today is going to apply still to .NET Framework. But let's talk about one that's not necessarily going to apply, and that's indexes and ranges. So in let's start with let's create here a basic array. I'll call it values. I'll just new up a basic array of 5 numbers. And I'm going to create a very simple method for printing this out. So we're going to console.writeLine. And we'll do a string.join as a nice way of converting this. We'll use the separator a comma and a space for readability and send in our array there. All right. And let's just show this working as a ground state of truth here. So I'll just display the values. And of course, this should be not interesting. We should get 1, 2, 3, 4, 5. And indeed, we get 1, 2, 3, 4, 5, right? Nothing exciting yet. All right, yes, best demo of the day. So now let's get a little more interesting. Let's say we want to display a new array that only contains the first 3 items. So I could use link. If I don't want to use link, I could also, I would have to write, use array.copy to create a sub-array of this array. So to do that, I'll need a destination array, var result, and I'll be a new integer array of 3 items. And then I'll do array.copy from our original array starting at index 0 to the new array starting at index 0 for the length of 3 items. And then I can display that result. So I expect this to give me an array of 1, 2, 3. There you go. But look how much boilerplate I had to write just to copy an array. So there's got to be more expressive ways to write this. And with link, you could do a little better. But there's a new language feature coming to C# 8 called ranges that lets you automatically pass in a range. And there's overloads built in that give you the subarray automatically. So instead of just creating a new array and copying stuff over, I could just do values. Starting from the 0th index, I want to take 3 items, or 4. Yeah, I think that'll give me what I want. But ooh, okay, here's an issue. There's an error. So the first thing you have to be sure, if you're using C# 8 features, you have to make sure you've enabled C# 8. Now, I think I already have in this demo. I'm not sure if it actually carried over to this new project. So let's take a look. Now, it's kind of hidden. It's considered an advanced build feature, even though I think personally it should be up at the application level. But you go down to build, and then you have to scroll down. There's a small little button called advanced. And then you get to choose what language of C# you want to develop against. I really hope this gets pulled up so it's not as buried as it is. But the default in Visual Studio 2019 is to use the latest released version of C#, which at this point is 7.3. Other options you can choose is the most recent major version, which is 7.0 as of this time. And that was the default under Visual Studio 2017. But people complained that they weren't able to start new projects using the new features, so they changed the default from user feedback. You also now have latest major, latest minor. Then you also have this new one called unsupported preview of next C# version, which is called preview here. If you click preview, you'll always be kept to the absolute latest release of your Visual Studio, even if it's in beta. Or for today's purpose, I'm just going to manually select C# 8 beta. And keep in mind, this is a beta. If you have issues or problems, you can't go complain to Microsoft that things didn't work out correctly. That's kind of what you're signing up for by trying out this feature early, but it is fun. So I don't recommend writing any production code using C# 8 at this time. But if you want to play around with experimentations of what it might look like or your own personal projects, have at it. All right, so there's still an error. And if I show you what this error says, it's a predefined type system.range is not defined or imported. And this is the problem you're going to see using some of these features that depend on new types in .NET Framework. And Microsoft will not give you a NuGet package, at least not, that's the current plan, to fill in the gaps. But being a community, someone will always have those NuGet packages available. And even today, for the previews, they're out there. So if you go to NuGet, go to Browse, I'm just going to search for system.range, because that's the, I know, feature I want to pull in. And you'll see 2 possible options. As of this recording, the first one is not compatible with the preview released in 2019. But the second one, mb.system.range, is fully compatible. So if you pull that in and install, the latest version at this time is 1.1.1. And it's going to ask you to install a few support libraries. These are all released by Microsoft, so stuff like buffers, numerics, memory. Nothing to be scared of there. You probably already have them in your project, to be quite honest. And then if we go back to the compiler, then that issue goes away. Yes. And then we can run our code, and we should still get 1, 2, and 3. There you go. Behind the scenes, at least in this version, result is still an integer array. It's just a better syntax for getting that integer array. Now keep in mind the beginning is inclusive and the ending is exclusive. So index 0 is the start of our array, and it'll continue right up to before index 3. So it's going to be, this is a 0.3. We'll get items from index 0, 1, and 2. And the end is exclusive, so you can represent the end of an array and get the entire thing. So in order to get, let's say, there's got to be a better way. So like, I don't know how long the array is, and I could probably write something like values.length -1 or something like that in here. But that's going to be annoying. That's not going to help us out. So instead, if you want to get something from the end, you can do a hat symbol, right? Caret, and then whatever index you want, and it's counting from the back of the array. It's still doing system, values.length or array.length minus whatever number you put here, but it's a better way of expressing that intent. So in this case, I'm actually going to be printing the entire array. Let's just show that happening. So I'm actually specifying a range over the entire array. If you're going to do that, now 0, right, is probably the default. That would be a sane default. So you can omit the starting point, and that's assumed to be 0. You can also omit the end, and that'll assume to be that hat 0. So in this case, this will get you the same thing, a full copy of that array. Show you that working. There you go. All right, some other fun things you can do is you can just start at index 2 and then get the rest of the array. Mix and match these however you care to, and gives you some great options. Another cool thing about this is actually helper syntax for creating a type of system.range. So I can pull that out to its own variable. I'll just call it range uncreatively. And I can pass that range to the indexer. That's perfectly fine. The helper syntax is basically constructor logic for creating a range. And I'll show you there's also something indexes that we can work with. So let me put a debugger in here. And let's start this. And let's take a look at what range actually looks like. So under local, let's see, there's local's range. Let me zoom in here. So range is an actual type, it's system.range, if you can see over to the right-hand side. And it contains a start and end. And if you look what start and end are, they are system.indexes. So range is just two indexes combined together. Now that means the index stuff works by itself too. So what we can do as well, if we just want to get the last item, so we can just console right line the last item here, and we'll hide our display. So we'll write values. To do the last item traditionally, it would have to be values.length -1. Let's kill our display at the moment, and our ranges for all that matter. So run this, you'd expect to see, of course, the number 5. And unsurprisingly, you do. But we can use an index to express that differently. We can replace this whole part with just the caret symbol. And functionally, it's identical. Now, yes, there's slight overhead to doing this because you have to create a new type, a new instance of a type along the way. But if that's the slowest point of your code, you have amazing code. So I wouldn't worry too much about the performance impact of this. Run this, you still get 5. All right. Now, there's no checking at compile time about the length of your array. So if I get the 100th item, this will compile perfectly fine. It's just a number. But of course, running it is going to be a bit of an issue. So it doesn't give you compile time checking. It's just a convenience for specifying a range or an index of an array or a collection. And then there's helper methods built into the framework for passing those into indexers. Yes? So that'll be a range. That will also probably not work because there's no 100. Yes, sorry. So the question was, what happens if you write 0.100 like I have done on this display there? Let's see what happens if we do that. That was the question. And yep, it tries to iterate over all those items that we specified, and we get an index out of range exception or something along those lines. So good question. Yeah, it doesn't give you that protection. It gives you the convenience for expressing the iteration over that, that sub-collection. Pretty cool. All right, so that's indexes and ranges. Are there any questions about any of that? One thing I do want to reiterate is that they are just constructing types. So you can construct your own types. You can accept an index and a range into your own API methods to use. And there's a lot of flexibility now that you have. Now, everything I was showing you is on .NET Framework. So my runtime here has been .NET Framework, and we pulled in a NuGet package to fill in those missing types. The same approach is going to be possible for Async Streams, but default interface methods, you just have to be on .NET Core 3.0. There's no way to get around that. There's no NuGet package you can pull in that's going to give you extra functionality. So let me go ahead. I'll show you how to do this in .NET Core, because it's in Visual Studio 2019. You still have to do a little bit extra work to get that enabled. You've probably seen it in other talks today, but just in case you haven't, I'm going to go through that. So I'm just going to close Visual Studio, start right back from the beginning. This time I'm going to create still a console app. We're going to just keep with console apps today. They're simple for language features. So let's create a new project. This time I'm going to, right at the top, is a console app for .NET Core. Okay, let's go there. I'm uncreated with my names. Give Visual Studio a moment. So now I have a .NET Core app. So if I wanted to program against .NET 3.0, you actually have to enable that targeting. And it's not just going into object, you're going to your properties for your assembly and enabling 3.0. There's another feature here preventing a casual person from accidentally doing that. They want to make sure that you as a developer 100% want to do this. So you have to go under Tools, and then Options. If you just search for the word Core, that'll bring up some .NET Core options. I don't have ASP.NET, and so I have less options than you may see. If you go to the .NET Core section, there's this Use Previews of .NET Core SDK. Now, I already have that enabled, but for you, out of the box, that will be unchecked. So you have to check that and then restart Visual Studio for it to come into play. After you make that change, you can go into your project properties, so long as you actually have .NET Core 3.0 installed. You can then select your target framework of .NET Core 3.0. And then you can go into your build settings as well and choose C#8. And that'll get you started. Now, if you're on .NET Core, there's nothing actually you have to pull in from NuGet. We can do the same similar thing right here. Actually, index and ranges work on strings as well. So I could just say, give me the substring from 6 onward of this. I don't have to pull in any special NuGet libraries because it's already built into the framework. If I run this, I just get world, which is my intended effect. So index and ranges also don't apply just to numbers and arrays. It can be used for anything that's potentially anything that's enumerable. There are some restrictions, but something like a string as well. So getting substrings now should be a lot easier than it has been in the past. All right, so I'm going to open up. So let's move over. Actually, we're going to spend the rest of today's time in .NET Core 3.0 with C#8 enabled. The next feature I want to talk about is Async Streams. So async came to the framework a while ago. It allows us to free up the thread while we're waiting on input from some other process. Maybe it could be in a database, maybe be a streaming IoT sensor, but something that's long running, hundreds of milliseconds, or maybe even 50 or milliseconds. Just doesn't have to be seconds, just even milliseconds is long to a programmer. We don't want, especially if we're running a server, we don't want our threads to just sit there waiting on data to come back and then running out of threads. We want all our threads to be servicing customer requests. So that's why we use async, so that threads can do other things while we're waiting on data. But enumerables were never included in this. So you could get an entire enumerable via an async. But enumerators are basically like generators, right? So they can run over time. They can be programmatic. You can have an array that just all values sit in memory, or you could have something like a database reader that reads and records one at a time. So if you want to wait on each individual record for an enumerable, there was no way of expressing that in C# or really as all of .NET until now. So newly introduced is it's called Async Streams. What it's actually doing, it has nothing to do with actual streams in .NET, but it has to do with async enumerators and enumerables. So here's an enumerator. We're generating 10 integers from 1 to 10, and this is a very slow generator. So it's going to take half a second to generate a number. It doesn't take too long when we run it, because it's just half a second, but it's kind of annoying. You can at least see that the delay is happening. Now, let's say I don't want my thread to sleep for that long. I want my thread to be freed up and go do other stuff. So I want to make this await. Well, await only works with task or task-like types, and thread.sleep doesn't support that. So instead, we'll move over to the async version, which is task.delay. All right, great, that works, but it's giving me an error, so that I can't use that here. Let's see what the error is saying. It's saying the wait operator can only be used with an async method. Consider marking the method async modifier. Yeah, basically saying if you want to use async, your method has to be async. So we'll go ahead and make the method async. And that should kill that error. Great, but now there's a new error on the method. Let's take a look at that one. This one's saying the return type of an async method must be task or a task type thing. But now notice in C#8, there's two more options, async enumerable or async enumerator. So let me move from my enumerable to my async enumerable. And that method's now very happy. But of course, the whole stack continues to go up a little level. Now calling generate ints cannot be called because main is not async. Well, let's make main async. That's available in C# 7.1, I believe. So we can convert it to an async task, not async void, but async task. There's a lot of negatives with using async void. Please never use that. At least have an empty task that returns nothing. All right, great. But now there's still an error. So the error in this case is that for each by itself does not understand the new async iterators. You have to use a special await version of for each. So there is a bit of a cascading effect, but this produces the same effect as if you would be calling any other async method, except for the async for each. Run this again, you get the exact same effect as you did before. But this time, our thread's freed up in the background. If we're on a server environment, like obviously it doesn't matter for our simple demo here, but in a multi-server environment, our threads are now free to go do other things. Excellent. Now what about cancellation? Well, let's create a cancellation token. So we'll new up a cancellation source. We'll go a token source. And I'll create a new cancellation token source here. Now in order to use this right now, I would have to have the method accept a new argument that is a cancellation token. Cancellation token. And if I want, I can just set it to default, so I can make it optional. So then I can pass in my token source dot task, or token, sorry. And then if I want, let's say after I iterate for the item, for the first item, I'm gonna, let's say, just cancel. So token source dot cancel. And then in order to get this to actually work, I have to make sure to pass my token down to all my other await tasks. So I'll pass that down to task.delay. Now when I run this code, I should expect to print out the first item, but then we're canceling it as soon as we get the first item, and we'll see what happens. All right, so I got item 1, but then I also got a task canceled exception. And that's perfectly fine. That's kind of what you'd expect in this case. You'd have to handle that. But there's a lot of overhead here, and there's a lot of stuff I didn't do, and it doesn't handle it gracefully. And a graceful way of handling a cancellation in a stream like this may be just stop the stream. So they didn't add this in initially, but there are plans to add in better support for cancellation to async streams, so that this is all done automatically. You don't need to have your method accept a cancellation token. You don't need to pass that around, or if you want to pass it around, there's talk of having something called cancellation token, just existing in context that you can call, kind of like yield and return. And then your generate ints will not pass in the token, but there's an extra method you can do here called with cancellation. And you can pass in a token, a cancellation token here, and everything would get hooked up. Now notice the API actually exists, but the compiler doesn't do anything with it right now, so this won't actually work. But this is what the goal is in the near future. Excellent. Any questions about async await? All right. Then we'll move on to talk about a bunch of smaller little features. Oh, I clicked the wrong button. All right. So the null coalescing operator is brand new to C#8. And what this is, if you're not familiar with the null coalescing term, is basically saying I have a variable, and if the variable is null, I want to set it to something else instead. This is the simplest version of this you can write, or most expressive, or least expressive, but most straightforward way to write this. I have a string that's foo, and it is null. If it's null, I'm going to set hello to code camp and then write that out. So of course you run this, and you unsurprisingly get hello world. You get a hello code camp. All right, but another way of writing this could be foo equals foo, and then you can do null coalescing to hello code camp. This is logically the same thing, but what's happening here is, first of all, the right-hand side only runs, right, if the item itself, if foo here is not null, and then the assignment occurs. So, but there's still a little bit of boilerplate here. Foo equals foo, you have to include the name foo twice. So in C#8, there's a small convenience feature. You can just set this equal to question mark equals. So we have a null coalescing assignment now, and that's a little bit more straightforward. It's behaviorally the exact same way. This is just syntactical sugar, but it's a nicer way to express this concept in your code. And in C#, at least right now, for nulls are kind of a thing, and you probably have this code somewhere in your code base right now. To prove to you this still runs, this still looks good, you get hello code camp, we're all happy. Next thing I want to show you is constraint types. This has to do with generics and kind of what you can do with null in the context of a generic. So this is a method, generic method. I accept anything called t. And if t is null, I'm going to write out that's null. So I'm going to pass in hello world first, and that's not null. So I expect this to say nothing, right? I'm not displaying anything if it's not null. But now if I pass in a null item, let's say a null string, I expect it to say, well, that's null. Great. Now, one thing I can do, I can always do the equals equals here, but if I try doing is, at least in previous versions of C#, it's going to give me an error. The is keyword could not be used if you had what's called unconstrained generic type. So if I added a constraint, if I did like where t is class, then that's okay. But otherwise, that would not be allowed. That was kind of silly. There was really no reason for that, so they've made a few tweaks to the compiler, and that's now perfectly acceptable. This works in C#8. That's null. The next feature I want to show you is called alternative interpolated verbatim strings, which is a very, very long description for an incredibly simple feature. All right, so basically, in C#, you now have the ability to write it's called verbatim string, and that's with the @ symbol here. And that turns off processing of special character escapes. So I can include the slashes right in the string. I don't have to worry about escaping them. Very convenient for path creation. You also have the ability to do an interpolated string. So instead of using string plus string plus string plus, you can create these so-called holes inside of the string and fill them with variables. It equates to string plus string plus string, but it's easier to see and a lot easier to process than using string formatters. But in order to do this, you had to remember the $sign had to go first, and then the @ had to go second. It's kind of a hard, silly piece of trivia to have to remember. So in C#8, they've tweaked the compiler that any order of these two variables is perfectly fine.
Which one goes
faster? Depends on your typing speed. So of course, it still works. Here, it put in the name Scott into my path. So you don't have to remember that. There's less mental overhead, yes. The next cool thing is called static local functions. So in C#, I forget exactly what version offhand, but in more of the recent versions, you can have what's called a local method inside another method. Very, very useful for recursive iterators. One of the benefits to doing this is you can actually form a closure over that second method. That is, without explicitly passing a variable into the method, it can reference things in the above scope. So for example, in this case, I'm declaring a username within static local functions. By the way, this static here is just for demo purposes. It has no effect on this feature whatsoever. If this was just without static, it would work, but it won't work because I'm a very simple program here. But that is irrelevant for what we're talking about. We're talking about this function here. So right now it's not static, and I'm passing in nothing, but it's still going to be able to reference my username. And that's through the magic of something called closures. Now, this could lead to unintended side effects. So it's sharing memory now, and depending on what you do with that memory, it could be shared across threads and start getting into dangerous situations. So if you want to be sure that there's no closure formed, you can write a static void, and that prevents the creation of a closure. It also now gives me an error. If I try running this, right, it won't compile because now it can't access the username variable I have. You can still give it arguments, call it name for clarity's sake, and you can still pass username through, but the automatic magic that's happening under the scenes to make that happen is turned off. So that gives you better protection in certain cases to make sure you or no other developer accidentally references a variable outside of the scope, which would accidentally create a closure. And if you're doing multi-threaded applications and sharing memory, that could lead you in a bad state. All right, so next thing I want to talk to you about is new pattern matching features coming to C#8. First, there's something called the switch expression. So a lot of times with the switch statement, you are using it to assign a variable. Choose one of the possible options and assign it to a variable. So in this case, we have a message variable. I'm assigning either first, second, or third, depending on what I'm getting in. So they're good. So in C#8, there's a better, more expressive way of writing this. Because this is kind of a lot of code for a pretty simple feature. The first thing we'll do is set the message directly equal to the switch instead of having to declare it ahead of time. And then if you do it this way, you have to write it a little bit differently. It's not switch I, but it's I switch, and there's no parentheses needed. Now, the cases are still quite heavy. Wouldn't it be a lot better? You know, the case word here kind of doesn't really provide us much information. We all kind of know what that's doing already. We already are doing a message equals on line 18 here, so we don't have to have those repeated everywhere. Let's just prevent fall through entirely, and then we don't have to worry about breaking or returning. And then we're left with something like this, which looks a little weird. So C# uses the lambda, it's not a lambda function, but uses that lambda arrow in all sorts of places. Let's use that here. And then instead of statements, let's make these expressions. Okay, do this for the others. Do this for the third one as well. Great. And then this is now it has to be executed because this is a single line of code. All right, perfect. So if we run this, right now I'm passing in a 2. I expect to see seconds. And in fact, I still do. Pretty awesome. So a nicer way of writing this in line. I don't know. Does it allow you to? Sure, if you want to. Wasn't that some kind of compatibility thing with IE back in the day in JavaScript? Yes, so it's actually giving me a warning here. I'm going to hover over the warning and zoom in. This switch expression does not handle all possible inputs, meaning it is not exhaustive. So what's going to happen there, if I pass in a number that doesn't match, like let's do 20, it's not going to just automatically choose a default value for me. It's going to say, I can't do anything. It's not exhaustive. I can't choose an option. It's not going to default to anything. So to avoid that, you want to be sure to provide a default option. And the default option here is using the discard symbol. And then you can do something like i.toString. And that gives you your default item. So it's not a compile error, but does give you a warning in the compiler that, hey, you might be doing something a little bit wrong. It's your choice whether to, at least at this time, it's your choice whether you want to actually make it exhaustive or not. But beware, if you don't, you take the risk of getting runtime exceptions. Cool, that's switch expressions. Nice new feature. Next thing we're going to talk about is the property pattern, and we'll also talk about the recursive pattern this time. The question was, can you throw the default in the first item? Does it have to be always at the last? Or does the position of the default matter? Yes, so you'd be fine with that. So here, you're asking, can I just move this all the way to the top and will it still be okay? I believe it should be fine. Actually now it won't match anything else because the default value first. So you'll be okay. So if you want to match everything to the first here, I mean, I guess it's giving me a compile time error because the others can never be reached. Or is that the error it's giving me? All right, let's talk later. I'm not exactly understanding right now, but find me after and we'll chat more about that. But you could just also provide a switch statement with only a default value. Really silly, but technically possible. And this would actually work. I don't know why, but you could. All right, so let's go back to properties and recursive patterns. Now, in this case, I have a bunch of menu items. I work for Grubhub, so unsurprisingly, we're restaurant-based here. And I'm going through and printing out all of the items which are a drink and are priced in USD. And in this case, that should just be my expensive Sprite. So it's printing out a Sprite that's $7. But let's express this in a slightly better way. So I could also express this using property patterns at this point. So instead of specifying item.category or item.price, I could just specify that the item has a category set to drink and also has price, let's say, set to price of currency here. Well, actually, the price one's a little more difficult, right? So it's not giving me any error on checking that the drink's okay. That's valid syntax in C#8. That's a property pattern. But if I want not the price, but the price is currency, now I have to use recursive patterns. So I have to provide a pattern and apply that to the price itself. So let's, within the price, check for the prices has object having a property called currency, and that's set to USD. Nicely taken care of here is the null check. We don't have to worry about that. That's in the framework for you. So if I run this, we're perfectly fine. There was a quick null check in there before. You don't have to worry about that. You can also, within the syntax, capture variables. So I can, instead of doing item name and item amount, I can capture the name as simply name, or var name var, or var name. And then I can similarly, instead of doing this.price.amount, I can capture that up here as well. From the recursive side, I can do var amount, spelled correctly, and then change these variables down here. And then it works as well. So we still get our Sprite, $7, just as we did before. The changes in C#8 are the ability to match against properties, and the ability with that to be able to then go through and add a recursive pattern. And I don't think there's much limit. I haven't checked out how far deeply you can actually go with these. My only advice is if that's a concern to you, you're probably not writing very clean code. So I don't know how far you can do experiments for yourself. I don't know if they actually programmed in a limit. And that's property and recursive patterns. The next pattern I want to show you is positional, basically working with deconstructors. So deconstructor is a nicer syntax for pulling out values from an object and setting them to variables immediately. So these are actually tuples now. Before they were just objects, but these are just tuples now with name parameters. And I'm pulling out the item that has a category of food. So instead of doing item.category food and then having to do item name, item price, I can check for item is, and then within here, it's basically checking against all the deconstructed values. So I can provide, I don't care what name, so I'll ignore that, let's say. The category I want to be food. I don't care about the price, and I don't care about the description. Now, this tuple has 4 items in it, so I have to provide 4 positions in the pattern. For positions I don't care about, you can just use the discard, and that matches anything. So if you run this, I guess I didn't show you that before, sorry. It'll match my pizza, which is the only food item I had. And within here, because recursive patterns works fine here too, you can do property checks. You could also properly go through and say you can capture variables. So I can capture the name here, just as I did before, var name. You can also capture the price, var price, and then reference those down here instead of item dot. And then if you want to do another property, so string has properties. A string has a length. Let's say I want a length of 11 characters. Because I think it looks to me like 12-inch pie is 11 characters long. Running this, that description matches. Obviously, I knew that ahead of time. And then the pizza is still displayed using those captured variables. Awesome. Any questions about any of this pattern stuff you've seen so far? One question, yes? The question is, when I do var name here, is that creating a new string, or is it getting a reference to the existing string? And it's creating a reference. It's creating a variable pointing to whatever we're capturing. The last thing I want to show you with patterns, with all the stuff, you can make switching on tuples a lot easier. So before, the best you could always do, as soon as you had patterns, this expression here, we're going to switch on a point of x and y, that's a tuple. And then we're going to check that the tuple is equal to 0, x0, y0. And if it is, we're going to print out center, which we are. So this was always kind of obnoxious. You had to do t.x, t.y, all the different values of the tuple in order to match them, until you had tuple equality in a later C#7 version. And then you could just do t equals 0, 0. I lost an n there. And that'll work. That's a little bit more expressive. But this is basically the positional pattern, so we can just delete the rest of this and use the positional pattern here. And it's going to check that both positions of that pattern are set to 0. Run this, and it still works. So now you can use these tuples more directly in your switch statements and switch expressions to be a little clearer. In your switch statement, if you want to use them, that's fine. They still have their place in the code. Right now, this kind of looks weird. You have to, the outer parentheses are the tuples condition, and the inner braces are create me a tuple. So the switches condition and the tuple creation. If you have this case in C#8, you can simply ignore the doubles, and this will switch on create a tuple of x and y. And that all works nicely. There's also enhancements to the using statement. One is if you have a lot of different chains, you might have code, especially if you're doing direct SQL connections, that looks like this. Typically with SQL connections, there's 3 things you have to use, or you should be using, to control the lifespan of that. So if you have code, you pretty much stack them up this way, using, and then the last one has the braces. If you have standard rules going against your code, the first 2 are in violation, because if you have standard rules saying you must have braces, the first 2 line here, 16 and 17, are in violation of that. So you might have to add some special rules. And if you have to do anything between these instances, you're going to have to not follow this pattern. So for example, it should display whatever something instances, then unwind it. So it should display cleaning up 3, 2, 1, because in my short-lived class here, as soon as it cleans up, it just displays the instance ID. So running this gets me goodbye. It displays something instances, and then 3, 2, 1 kind of cleans it up. So if I wanted to change an instance ID of 1, so if I wanted to do, let's say, instance1.instance equals, let's say, 42 instead, this compiles and runs, but it's not going to run the way I expect it, because now it's only this statement that's within the scope of the using, and the others are in a different scope. So if I run this, I'm going to see that the instance of the first one, which I changed to 42, gets cleaned up earlier than I intended. If I don't want that to happen, I have to add braces. And then we lose the beauty of the code. We have an indentation problem. So in C#8, you can omit this the statement here, or omit the using statement, and then just switch them all to a new form of using that will do the cleanup at the end of whatever scope you're currently in. So delete these. So this, however, works perfectly fine. It's going to create instance 1, 2, and 3, display something, and then unwind the stack. Excellent. So the dispose is happening right at the very end of the block here. If you just create your own blocks willy-nilly, then that's going to change the lifespan of that using statement. So in this case, that'll go back to getting rid of the first one first. So in certain circumstances, if your code's a little ugly, you have a chance to clean them up. The smallest feature, but pretty useful if you're in this situation. Now, is anyone here actually doing low-level development or high-performance coding in C#? I got 2 people raise their hands out of a room of about 50 or so. So people are. So there have been a lot of changes to the language to support your use cases. So while this next one won't apply to everyone, for those in the stream, it might be quite nice. I'm going to delete the short-lived here as well, since we're only going to use this foo. This foo is a reference structure that's relatively new. That means that this structure can only live on the stack, can never live on the heap. It can never be boxed. And because of those restrictions, it cannot be implementing an interface. So if you wanted to use this in a using statement, there's no way you can implement iDisposable. I'll get to you in a sec. So instead, in C#8 now, there's a pattern matching specifically for ref structs. If your ref struct has a dispose method that takes no arguments, returns a void, you can use that in the context of using either the old way or the new way. And then this will work exactly as you expect. So it'll do A, it'll do something. I ran out of fun things to say. It'll do B, and then it's going to say it's disposed. So if you're using a lot of ref structs nowadays and you want to dispose of them, you now have an ability to do so. Before that just was not possible. There was a question in the back? Yes? Support what? And I don't know what you mean by supporting embedding. The question was, will C# support embedding? I'm not quite familiar with what you're asking about. Let's chat after, because I'm running a little short on time. All right, next thing I want to show you is nullable. This is a brand new feature being introduced in C#. It's being introduced softly, and it basically changes the way nulls are treated by the compiler. So in this case, I'm providing my name and a null to something called print name, and I'm printing hello, first name, last name. So run this, I'll get hello, Scott, perfectly fine. But I'm actually getting a warning here. And if I zoom in, this warning saying cannot convert null literal to non-literal reference on unconstrained type. Okay, the name is, the description is absolutely awful, but it's trying to give you an error that's trying to describe to you that, hey, you're passing a null, but string last name doesn't declare that it can accept a null. And this is the new thing in C#8 with this feature enabled. This does not come enabled out of the box. So in order to enable this warning, I actually went to my project, and there's tutorials online on the MSDN blog about this, or the Microsoft blog, about adding this nullable context options to enabled, and that'll allow this to happen project-wide. So then if you have just a reference type, it's assumed that it is not nullable. Now, it's not actually enforced. It's just enforced through these warnings, so it's not going to prevent you from compiling. It's not going to prevent you from actually still getting into bad situations, but it's starting to give you some guidance as a developer where you might have potential bugs. So to satisfy this, I could do two things. I can do, first of all, I can use it's called null forgiving operator. This is a very simple demo, so of course I do the silly things in simple demos, but it's basically saying turn off this warning. Null obviously is a very silly way to use this, but if you have a variable you're passing in, and the compiler doesn't think it can never be null, you can override that warning and say, I know that it cannot be null, so forgive me for this error. The better way of fixing it, though, is to first either actually provide a value, or you could provide or not call it if the value is null. So here, well, let me show you that in a different way. The next thing I want to show you before I get to that is how can we accept then a value with a null? Obviously, there's legitimate cases for this. You can't tell me I can't pass around nulls anymore. You can, but you have to add a question mark at the end of the type to say, I accept nulls. This kind of like string. Now, this is completely separate from nullable value types. So this does not convert this type in any way, shape, or form. It just allows you to pass in a null without giving you a compiler warning. And that warning on null here went away. Here, I'll zoom in. There's no squiggly there. Okay, so, but let's say I do want to, let's say I'm like this now, and I want to do something. I don't want to print out my name. I want to print out my name in all caps, screaming name. So I can do static void, static string. We'll convert my name to caps. So I'll just write a 2caps function that takes in any string value and returns the value converted to uppercase. And then let's say the last name, I want to be screaming the last name. And of course, button pressing's hard. So 2caps. And then I get an error, a warning here, same thing. I'm trying to pass this, which can be nullable, into this method, which does not allow it to be null. Now, another way I can solve this is doing a null check. Now, his last name is not equal to null. Then I want to go ahead and run that null check. So this code will not run if the last name is null. And the compiler is doing code analysis. It's smart enough to see that it's not possible at this point in time right here when I'm calling 2caps for it to be null, so the warning also goes away. So that's really cool. So in flow analysis and everything. Now, the forgiving operator there is because sometimes the analysis from other assemblies that aren't compiled with this feature, we have no way of knowing what the promises are from that. Now, when you do run this, it will be compiling the output of the null flow analysis into the metadata of your compiled code. So if you're using other code compiled this way, the flow can still continue based on what they compiled as. They could, of course, lie, but let's say they're not. But even if you do get in some situations, the null forgiving operator is there as a way to give you an out. Let's say I didn't have this and I wanted another out. Let's say I can't change to caps or print name at all. So print name, I cannot change this from a third-party library. So I'll get my error back. I can also disable processing of this feature for certain areas with a directive. So I can do nullable enabled at the end. Enabled. And then the warning goes away here too, because this is out of scope for null checking. Now you can actually do a few things here. You can do exclusively this. So here I've enabled my whole project to be nullable, which is not a bad idea for new projects once C# 8 is release finalized. But then if you have a project that's hundreds of thousands of lines of code, it's going to be really difficult to change that. So instead, you can opt in instead of opting out. So in here, I'm going to take away my enable. And then now I can, everything's disabled by default, so this is really not doing anything, but I could enable my code for just this block, which is all okay. But if I move the enabled up to also encompass the main method, then I get my warning back. Oop, there it is. So you can do this piecemeal any way you want, either do a whitelist or a blacklist essentially through these. There's also the case of string x equals null, which is probably popular in your code. This does produce the same warning. There's another level you can do. Instead of enabled, you can do safe only, which is exactly the same as enabled, but has an exclusion for this specific case, which does occur quite a good bit. And then instead of disabled at the end, you can also do restore, which will bring you back to basically keep a stack of where you were at before your last statement, and it resets it at the end. That might be better to make sure your code doesn't accidentally keep things disabled in places where you don't intend it to be. All right, that's nullables. There's a lot more. Those are the basic features. When you start getting into this, there's lots of edge cases. So on the blogs for the language design team, there's great explanation about a lot of those different specific edge cases. Now, we are a little short on time. I'm probably going to go just a few minutes over. I want to show you 3 features that are coming up to C# 8 in the preview 2. We're going to be a little quicker with this. So here I've compiled the latest build. Right now, as of today, I compiled the master branch of Roslyn and put that in Visual Studio and made a few changes here. So I'm going to go over these a little briefly. The first one is called read-only structs. Without getting into too much detail, there's problems if you read values from structures. It sometimes gives you an entire new copy of the structure instead of just the value you expect. So in this case here, this is one instance of a similar error. It's not an error, it's a warning saying, hey, you can do this, you can read this value, but it could result in an implicit copy of the entire structure. And that happens when I want to try to make changes to it. So I can, in C# 8, mark it as read-only. Now, in this case, I'm trying to call length squared, which is not marked as read-only. But if I mark it as read-only, then this error goes away. Because read-only now tells the C# compiler that this specific method is not altering the state of the structure, so it's safe to give it back without or making a copy. And if you do put read-only in a function that is actually manipulating breaking the contract, manipulating a variable, it's a compile error and won't proceed. Now, you've always been able to mark a structure entirely as read-only, so this is not completely new. But now you can apply to individual levels of a structure if you have to have a mixture of read-only and mutable and immutable data in your structure. Another small feature is obsolete properties. So let's say I want to make this, I had a public API called version, and I want to mark it, and has a getter and a setter. But I don't want anyone to use the setter anymore. Being able to change the version of this is a bad idea. Version is what it is. You can't change it. So if I just put obsolete, which you can do in C# today, since 1.0 actually, I generate compiler warnings saying, hey, I'm trying to set the value and I'm trying to read the value. Both these errors, or warnings, sorry, are saying, hey, it's obsolete, try to move on from it. But instead now, you can actually move obsolete to just the setter or the getter. So if I want to disable writing to the version but still allow getting, then I'll zoom in here. If you notice, the setter now gives you an obsolete warning, but the getter is perfectly fine. So that's that new feature. And the last thing I want to show you is default interface methods. Now, this is the one that cannot run in .NET Framework in any way, shape, or form. And if you're using someone's library that has this feature enabled, you can't do that on .NET Framework either. This is a runtime feature, so you have to be full .NET Core along your entire stack, from your libraries to your actual executable, in order to use this. But the base feature is, let's say I have so here I'm having a interface that allows you to add and display. I'm adding 3 numbers and displaying them. So when I run this, now I can't run this through Visual Studio. There's actually a bug right now in Visual Studio where the compiler I told it to use instead, it's not listening to me. It's still using its own compiler. So I'll switch to command line. I'll go to demo 3 here. So here in demo 3, I'm going to do just .NET run really simply. And it'll display 4815. Now, let's say I want to add a range instead of each individual item. So I want to do add range, T, i enumerable, T, values. Now, what I've done is I have made a breaking change to my implementation. So right now I'm getting an error saying that this implementation doesn't work anymore because I added a new type. Now, it's fine if you're all keeping these internally to your app, but if you ship this interface out for others to use, you're breaking them and they will hate you. So instead, what happens if we make this have an actual function body and give it a implementation? So we can actually go through for each var v and values and just call add v on each one. Since there's a logical action we can take that relies only on what other functions are available in the interface, that should be okay. So instead of add, let's do add range, and then we'll do a new array. Let's do just 4 and 8, and get rid of our other calls. So first of all, the warning goes away because there's a default implementation. It's okay that this class doesn't implement that method because there's an implementation for it on the interface. So if I save this, oops, wrong shortcut for save this, and run again, it should be 4 and 8. We get the same code, works perfectly fine, but this time it's using the add range method that's implemented on the interface. Now, let's say I can do better. I'm a list, and list has an add range that may give me better performance. So I can still implement add range on this method. So I can do public void add range. I can pass in I enumerables. And these are of string in this type, values. But to prove it's actually taking this implementation instead of the other one, I am just going to do storage.add. And what the Star Wars coming traction came out last night, so I'll do Star Wars. So now I provided that method, so I expect that one to take precedence over what's in the interface. And indeed, if I run this, instead of the 4 and the 8, I get my Star Wars instead. Now, there is talk in the prototypes whether the override keyword is needed or not. As of now, it's not. It's still subject to change. Also, this is early prototype code, so I have to specify the type of the interface here for this to work correctly. If I tried doing var, and if I did not have that type added to my class, the compiler would be very unhappy with me. And that's just because the feature is currently in development. So it doesn't like me, and it won't run, won't compile. But that's just because of a temporary feature. So I'm sorry. Thank you for staying over a little time. Sorry I used the 4 minutes of your lunch. If you have any questions, I know there was 2. Come see me after. We'll happily chat about them. Otherwise, thank you for your time.